April 17th, 1943, North Atlantic, approximately 400 miles southwest of Iceland. The hydrophone operator aboard UN 175 pressed his headset closer against his ears, straining to distinguish individual sounds from the chaotic acoustic signature above. Corvettenkäpitän Heinrich Bruns had ordered silent running 30 minutes earlier when ASDIC pings first echoed through the pressure hull, the telltale sound of British escorts actively hunting his submarine. The Type IXC boat hung motionless at 150 meters, her crew frozen at their stations, breathing shallow to conserve oxygen and minimize noise. Every man understood the mathematics of survival: remain undetected long enough for the escorts to abandon the search, or surface when batteries and air were exhausted and face destruction by gunfire. What none of them could anticipate was that within the next 4 minutes, they would encounter a weapon that would fundamentally transform anti-submarine warfare, rendering obsolete the very tactics that had kept German U-boats alive since the First World War. The sound, when it came, was unlike anything the hydrophone operator had ever heard in 2 years of Atlantic patrols. Not the distinctive splash of conventional depth charges hitting the water, followed by the agonizing wait as they sank toward preset detonation depths. Instead, a rapid series of smaller splashes, 24 distinct impacts occurring within seconds, creating a pattern that made no tactical sense according to German understanding of British anti-submarine weapons. Contact lost, the hydrophone operator reported to Bruns, his voice barely above a whisper. Multiple small impacts, bearing green 090, pattern suggests. He paused, searching for appropriate terminology to describe what his instruments had detected. Sounds like someone throwing gravel into the ocean, Herr Kaleu. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Bruns frowned at the report. His experience commanding U-boats since 1941 had taught him to trust his hydrophone operators implicitly. These men developed acoustic sensitivities that exceeded any mechanical instrument, learning to distinguish individual ship types by propeller signature, identify specific escort vessels by their engine rhythms, and predict attack patterns by analyzing the tactical movements of hunting groups. If his operator reported something anomalous, something unprecedented, then the British had deployed a new weapon. The question was whether this new weapon posed any actual threat, or whether it represented another experimental system that would prove ineffective under combat conditions. The answer came 8 seconds later, when the first contact detonation occurred. The explosion was sharper, more focused than a conventional depth charge, lacking the prolonged rumble that characterized standard underwater detonations. More explosions followed in rapid succession, creating a drumbeat of destruction that walked across the ocean floor in a precise pattern that brought each subsequent blast closer to UN 75's position. "Emergency dive! Take her to 200 meters!" Bruns ordered, abandoning silent running protocol. Speed mattered more than stealth now. If the British had developed a weapon capable of detonating on contact with the seafloor or a submarine hull, then depth variation might provide the only chance of survival. The electric motors engaged at maximum power, draining precious battery reserves as the submarine's bow angled sharply downward. Compressed air hissed through the ballast system, adding weight to accelerate the descent. Throughout the boat, men braced themselves against bulkheads and equipment, preparing for the shock waves they knew were coming. 3 more projectiles detonated, in UN 75's wake, close enough that the concussions hammered through the pressure hull. Cork insulation showered down from overhead, light fixtures shattered. The port electric motor screamed as its mounting bolts loosened from the force of the nearest explosion. In the control room, Bruns watched the depth gauge needle swing past 180 meters, 190 meters, approaching the boat's test depth of 230 meters. Every additional meter of depth increased the external pressure on the hull, bringing them closer to the point where steel would yield and the ocean would crush them like an eggshell. But remaining shallow meant staying within the killing zone of whatever weapon the British had just unleashed. The drumbeat of explosions ceased as suddenly as it had begun. The British escort, Her Majesty's ship Vanoc, a V-class destroyer that had been hunting U-boats in the Atlantic since 1941, had exhausted her first salvo of the new weapon. Commander James Rowland, Van Och's commanding officer, studied the ASDIC plot with satisfaction. The contact remained solid at bearing 090, range 800 yards, depth approximately 200 meters. His first Hedgehog attack had missed, the projectiles detonating on the seafloor 30 meters below the submarine's actual position. But the weapon had performed exactly as designed, providing immediate feedback about target location. Unlike conventional depth charges, which exploded regardless of whether they hit anything and temporarily destroyed ASDIC contact through acoustic distortion, Hedgehog projectiles only detonated on contact. No explosions meant a miss. The silence told Rowland precisely what he needed to know. The U-boat had gone deeper, evading the attack pattern. "Reload Hedgehog," Rowland ordered. "Set depth estimator for 200 meters. Prepare for second attack run." The Hedgehog weapon system, officially designated as the Anti-Submarine Projector Mark X, represented a revolutionary approach to anti-submarine warfare that had emerged from British operational research conducted at the Admiralty's Department of Miscellaneous Weapons Development. The basic concept was elegantly simple in theory, but had required years of engineering development to make practical for combat deployment. 24 spigot mortars mounted on a steel framework projected small bombs forward of the attacking ship, creating an elliptical pattern approximately 130 feet long and 140 feet wide ahead of the vessel. Each bomb, weighing 32 pounds with a Torpex explosive charge, travelled approximately 250 yards before hitting the water. The bombs sank at approximately 23 feet per second, maintaining their pattern as they descended. Contact pistols on the nose of each bomb detonated the charge only upon direct impact with a solid object. A submarine hull, the seafloor, or any other obstruction would trigger the explosion. Water pressure alone would not. This fundamental design characteristic differentiated Hedgehog from every previous anti-submarine weapon. Conventional depth charges, developed during the First World War and incrementally improved through the 1930s, operated on the principle of proximity kill. Set to explode at specific depths, they created massive pressure waves intended to damage submarines through shock effect alone. A depth charge exploding within 50 feet of a submarine could rupture the pressure hull. One exploding within 20 feet would almost certainly destroy the boat. The problem was that setting depth charges required accurate knowledge of the submarine's depth, information that was difficult to obtain and often outdated by the time the charges exploded. Submarines detected by ASDIC could immediately alter depth, moving above or below the preset detonation zone. Experienced U-boat commanders developed tactics specifically designed to exploit this limitation, executing rapid depth changes as soon as they detected active sonar pings from approaching escorts. Conventional tactics called for escorts to race over the submarine's last known position, dropping a pattern of depth charges set for various depths, hoping that at least one would detonate close enough to inflict damage. The attacking ship would lose ASDIC contact as it passed directly over the target, creating a blind zone during the critical attack phase. The massive explosions from depth charges created acoustic distortion lasting several minutes, making it impossible to determine whether the submarine had been hit, damaged, or had successfully evaded the attack. Follow-up attacks required waiting for the water to settle and attempting to re-establish contact, giving the submarine time to escape or maneuver for a counterattack. The Hedgehog system eliminated these tactical problems through several interrelated design innovations. By projecting bombs forward rather than dropping them astern, the attacking ship maintained continuous ASDIC contact throughout the attack. The escort never passed over the submarine, never entered the acoustic blind zone that conventional attacks required. The small size of Hedgehog bombs meant minimal acoustic distortion, even when they detonated against the seafloor. Contact detonation provided immediate feedback about attack effectiveness. Explosions meant hits. Silence meant a miss and the need to adjust aim for the next salvo. No guessing, no waiting for water to clear, no uncertainty about whether to continue the attack or search for a new target. Development of the system had begun in late 1941 under the direction of Lieutenant Commander Charles Goodeve, a Canadian-born chemist and physicist serving with the Royal Navy Volunteer Reserve. Goodeve's Directorate of Miscellaneous Weapons Development had been tasked with solving the acute problem of U-boat survival rates that threatened to lose Britain the Battle of the Atlantic. Statistical analysis of anti-submarine attacks conducted throughout 1940 and 1941 revealed troubling patterns. Escorts were making contact with U-boats regularly, conducting hundreds of depth charge attacks per month, yet achieving relatively few confirmed kills. The ratio of attacks to kills suggested that conventional weapons were fundamentally ineffective against submarines capable of rapid depth changes and evasive maneuvering. Goodeve assembled a team, including Professor Patrick Blackett, whose operational research methods would transform British naval tactics, and numerous engineers and weapons designers. Their mandate was simple but urgent: develop weapons that could kill submarines more efficiently than conventional depth charges. The survival of Britain's maritime supply line depended on success. The initial Hedgehog prototype underwent testing in May 1942 aboard HMS Westcott, a modified destroyer serving as trials vessel for experimental weapons. The first operational deployment occurred in October 1942, when several escorts were equipped with the new system for convoy protection duties. By April 1943, approximately 50 escorts carried Hedgehog, with production accelerating rapidly as effectiveness reports validated the weapon's revolutionary capabilities. The first confirmed kill using Hedgehog occurred in December 1942, when HMS Wanderer destroyed an unidentified U-boat in the Mediterranean. The submarine had been detected at shallow depth, hunted for several hours using conventional tactics, then finally destroyed by a Hedgehog salvo that achieved at least 2 direct hits. Post-attack analysis revealed that the contact detonation principle had performed exactly as designed. 2 small explosions had occurred, indicating 2 hits on the submarine's hull. No follow-up attacks were necessary. The U-boat had sunk immediately, leaving only oil slicks and debris to mark its grave. Aboard U-Own 75, Bruns faced the fundamental problem that would plague German U-boat commanders throughout the remainder of the war. He was fighting blind against enemies who could see him clearly through acoustic detection, while simultaneously deploying weapons he did not understand and could not effectively counter. Hydrophone reports propeller noise increasing. Bearing green 085, the control room talker announced. Escort is making another attack run. Bruns calculated his options with the cold mathematics of underwater survival. His batteries were depleted to 40% capacity after 35 minutes of evasion at depth. Compressed air reserves had been exhausted by the emergency dive, leaving no margin for additional rapid depth changes. The boat's trim was marginal, requiring constant adjustment by the diving plane operators to maintain stable depth. He could not run. The escort's maximum speed of 34 knots exceeded UNE 75's submerged speed of 7 knots by nearly 5 times. He could not hide. ASDIC could track him continuously at this range and depth. He could not fight. His torpedoes were useless against an escort maintaining stern aspect and standoff range beyond effective targeting solutions. The only option remaining was to attempt evasion through unpredictable maneuvering, hoping the British weapon, whatever it was, lacked sufficient accuracy to hit a moving target, executing random course changes. Right full rudder, steady on course 270, Bruns ordered. Maintain 200 meters. All hands brace for impact. The second Hedgehog salvo struck the water 200 yards ahead of Vannock's bow, the projectiles creating their characteristic pattern as they sank toward the estimated target depth. Commander Rowland had adjusted his aim based on the submarine's last known course and speed, predicting where it would be when the bombs reached attack depth. The calculation proved partially correct. 3 Hedgehog bombs detonated in rapid succession, their sharp cracks clearly audible through Vannock's hull. The ASDIC operator reported contact lost, the acoustic returns scattered by the explosions. But within 30 seconds, contact re-established. The submarine was still there, still moving, apparently still intact despite multiple hits. Rowland frowned at this report. Intelligence briefings had indicated that Hedgehog bombs should penetrate a submarine's pressure hull and detonate internally, causing catastrophic damage. 3 direct hits should have destroyed any U-boat. Either the intelligence was incorrect, or the submarine's hull was thicker than expected, or the bombs had struck non-critical areas. "Reload and prepare for third attack," Roland ordered. "This boat has extraordinary luck or extraordinary armor. Let's see how much punishment it can absorb." Inside UN-75, Bruns had no illusions about their situation. 3 small explosions had occurred against the submarine's hull, each sounding like someone had struck the pressure hull with a sledgehammer. The impacts had been forward, in the vicinity of the torpedo room, where hull thickness was greatest to accommodate the torpedo tube mechanisms and pressure-resistant hatches. Damage reports were mixed. The forward torpedo room reported minor flooding from cracked welds around the number 2 tube, controllable by manual pumping. The electrical system showed voltage drops, indicating short circuits in the forward distribution panel. Most critically, the bow diving planes were jammed in the slightly up position, making depth control difficult and requiring constant correction. "Herr Kaleu, we cannot sustain another attack," the chief engineer reported quietly, his voice audible only to Bruns in the cramped control room. The hull took 3 direct hits. The steel held, but the welds are stressed beyond design limits. Another impact forward could rupture the pressure hull. We should surface and surrender while the crew can still evacuate. Bruns considered this recommendation for exactly 3 seconds before rejecting it. UN-75 carried classified naval grid coordinates for the current patrol area, updated intelligence summaries about Allied convoy routes, and a complete set of current Enigma cipher rotors. Surrendering would hand all of this material to the British, potentially compromising every U-boat operating in the North Atlantic. "We dive deeper," Bruns decided. "Take her to 250 meters. The British weapon appears to be a forward-throwing mortar of some kind, creating a pattern ahead of the attacking ship. If we go below the attack pattern, we might evade the next salvo while their ship passes overhead." The chief engineer's expression conveyed his opinion of this plan without words. 250 meters exceeded the boat's test depth by 20 meters, placing stress on the pressure hull that the damaged forward section might not withstand. But orders were orders, and the alternative was surrender or certain death. Hydrophone reports escort at 600 yards. Closing rapidly, the control room talker announced. "Estimate 30 seconds to weapon release point. Emergency dive. Take her down. All ahead, full on the electric motors." The third attack missed entirely. Vanok's Hedgehog salvo struck empty water where UN-75 had been seconds earlier, the bombs sinking past the submarine's previous position and detonating harmlessly against the seafloor 200 meters below. Commander Roland realized immediately what had happened. The U-boat commander had gone deeper, probably exceeding safe operating depth in desperation to escape the attack pattern. It was a tactic that demonstrated both courage and tactical acumen, but it was also unsustainable. A submarine operating beyond its design depth could not remain there indefinitely. Material limitations would force it back to safer depths eventually, and when it did, Vanok would be waiting. "Maintain contact," Roland ordered. "Do not attack. Let the pressure hull do our work for us. That boat is beyond its rated depth. Every minute it stays there increases the probability of structural failure. We simply wait." The psychological warfare had begun. Both commanders understood the mathematics of material science. U-boat pressure hulls were designed to operate safely to specific depths, with a margin of approximately 10% beyond the rated depth, before catastrophic failure became likely. UN-75's rated depth was 230 meters. At 250 meters, the external pressure exceeded 1,400 pounds per square inch, testing every weld, rivet, and hull plate beyond their design specifications. Every minute at this depth increased the probability that some minor manufacturing defect, some microscopic crack, some barely noticeable corrosion would propagate into catastrophic hull failure. The crew could hear the pressure hull groaning under the load, steel plates flexing infinitesimally, rivets creaking in their holes, welds stretching at the molecular level. Cork insulation continued to rain down from overhead. Small leaks appeared at pipe penetrations, requiring constant attention from damage control teams wielding wooden plugs and hammers. In the forward torpedo room, already damaged by the Hedgehog impacts, the flooding had increased. Not catastrophically, but enough that the manual bilge pump could no longer keep pace. Water accumulated in the bilges, adding weight that dragged the submarine's bow downward, requiring increasingly desperate efforts by the stern plainsman to maintain trim. "Herr Kaleu, we have major flooding forward," the torpedo officer reported over the intercom. "The welds around Tube 2 are splitting. We cannot stop it. Estimate 5 to 8 minutes before we lose buoyancy control." Bruns had commanded submarines long enough to recognize when material reality trumped tactical theory. They could not remain at depth, they could not surface and surrender. The only remaining option was to attempt a fighting withdrawal, surfacing unexpectedly to engage the escort with deck guns, while the crew prepared to abandon ship. It was a desperate tactic that rarely succeeded, but it offered at least the possibility of inflicting damage on the enemy and allowing some crew members to survive as prisoners of war rather than drowning in a steel coffin. "Prepare to surface," Bruns ordered. "Gun crews to battle stations. Prepare to abandon ship on my command. All classified materials to the weighted bag for destruction." The British had not invented the Hedgehog system in isolation. It represented one component of a comprehensive revolution in anti-submarine warfare that had been developing throughout 1942 and early 1943, driven by operational research, technological innovation, and the desperate urgency of reversing catastrophic merchant shipping losses. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The Hedgehog's development paralleled advances in multiple interrelated technologies. High-frequency direction finding, known as HUF-DUF, allowed escorts to triangulate U-boat radio transmissions with devastating accuracy. Centimetric radar operating at 9.1 centimeter wavelength could detect submarine conning towers at ranges exceeding 10 miles in any weather. Improved depth charges with increased explosive charges and better detonators enhanced conventional weapons even as Hedgehog supplemented them. Perhaps most critically, the breaking of German naval Enigma ciphers by codebreakers at Bletchley Park provided Allied convoy routing authorities with advanced knowledge of U-boat positions, allowing convoys to evade wolf packs before attacks could develop. Each technology multiplied the effectiveness of the others. Ultra-intelligence identified where U-boats were operating. HUF-DUF pinpointed individual submarines making radio reports. Radar detected them on the surface at night. Hedgehog killed them when they dove to escape. The integrated system proved far more effective than any individual component. But for German U-boat crews experiencing these weapons in combat, the integrated nature of the threat was not immediately apparent. They understood they were facing new detection systems. They recognized that Allied aircraft were finding them with impossible frequency. They knew that conventional evasion tactics were failing. What they did not understand until months after the Rotterdam incident, when examination of captured British cavity magnetrons revealed the full extent of Allied radar capabilities, was that they were fighting enemies who possessed fundamental technological advantages across multiple domains simultaneously. They were not just outgunned. They were operating in an electromagnetic environment where enemies could see while they remained blind. Uone 75 broke surface at 15:32 hours. Her conning tower, emerging from the grey Atlantic, swells 800 yards from HMS Vanoc. The gun crews scrambled up through the hatches, racing to man the 88mm deck gun and the twin 20mm anti-aircraft mounts. Commander Roland watched the submarine surface and immediately understood the German commander's desperate gambit. Fight on the surface, inflict what damage possible, cover the crew's evacuation. It was tactically hopeless against a destroyer with superior speed, maneuverability, and firepower, but it demonstrated the courage that made U-boat crews so formidable despite their technological disadvantages. "All guns, Engage the submarine. Roland ordered. Do not close to ramming range. Stand off and destroy her with gunfire. Vanok's 4.7-inch guns opened fire at maximum elevation, their shells creating towering splashes around the submarine. The first salvo missed, falling short by 50 yards. The second salvo straddled the target, shells landing to port and starboard. The third salvo achieved a direct hit on Umone 75's conning tower, the explosion killing the bridge watch and destroying the submarine's ability to navigate on the surface. The German deck gun managed to fire 3 rounds before a direct hit from Vanok's secondary armament destroyed the mount and killed its crew. The anti-aircraft guns fired continuously, their tracers arcing toward the destroyer but falling short as range, and the submarine's unstable platform degraded accuracy. Bruns, wounded by shell fragments from the conning tower hit, gave his final order. Abandon ship. All hands to life rafts. Open the vents. We're going down. The crew of UN 75 evacuated their dying submarine in disciplined fashion, despite the continuing gunfire from Vanok and the chaos of battle damage and flooding. 38 men made it to life rafts before the submarine's bow dipped beneath the surface. 13 men went down with their boat, including Bruns, who remained on the bridge to ensure his crew evacuated before the submarine's final plunge. Vanok ceased fire as the submarine sank, her crew maintaining station at 500 yards while launching boats to recover survivors. Commander Roland watched the oil slicks spread across the surface, marking UNE 75's grave, and contemplated the tactical lessons of the engagement. The Hedgehog had performed exactly as designed, achieving multiple hits against a maneuvering target and forcing the submarine to surface where conventional weapons could finish it. The contact detonation principle had provided immediate feedback, allowing rapid adjustment of subsequent attacks. The forward-throwing design had maintained ASDIC contact throughout the engagement. Most importantly, the weapon had shocked the German crew, forcing them to confront the reality that Allied anti-submarine capabilities had advanced far beyond conventional depth charges. That psychological impact, the destruction of confidence in depth as a sanctuary, might prove as valuable as the physical destruction of the submarine itself. Among the survivors pulled from the Atlantic that afternoon was Oberleutnant Sir C. Franz Köhler, UN 75's executive officer and the senior surviving officer. During initial interrogation aboard Vanok, Köhler provided information that British intelligence found extremely valuable. "The weapon you used," Köhler asked through his injuries and shock, "it was not depth charges. The explosions were different. They seemed to detonate only on contact with our hull. How is this possible?" The British interrogator, a specialist in technical intelligence, recognized the significance of this question. The Germans did not yet understand the Hedgehog's operating principle. Their experience with the weapon had been limited to a single engagement, insufficient to deduce its full capabilities. This knowledge gap represented a temporary intelligence advantage that would not last once more. U-boats encountered Hedgehog and survivors were debriefed by German naval intelligence. "I cannot discuss specific weapons," the interrogator responded correctly. "But I can tell you that every U-boat in the Atlantic will face the same capabilities you experienced. The tactics that kept submarines safe last year are obsolete. Depth provides no sanctuary. Evasive maneuvering cannot defeat weapons that maintain constant contact and only explode on direct hits." Köhler absorbed this information in silence, his expression revealing the comprehension of strategic defeat. If the British had developed weapons that could track submarines continuously and strike with precision regardless of depth or maneuver, then the tactical balance had shifted irreversibly. U-boats could no longer rely on their traditional advantages of stealth, depth, and underwater mobility. The interrogation report, filed under most secret classification and distributed to Allied anti-submarine warfare commands, noted that the prisoners' psychological response indicated significant demoralization. German U-boat crews had maintained high morale throughout 1942 despite increasing casualties, because they believed their boats remained fundamentally superior to Allied anti-submarine capabilities. Encounters with weapons like Hedgehog shattered this confidence, replacing it with fatalistic recognition that technological inferiority made survival increasingly dependent on luck rather than skill. This psychological transformation, repeated across hundreds of similar engagements throughout 1943 and 1944, would prove as strategically significant as the physical destruction of submarines. The Battle of the Atlantic entered a new phase in spring 1943, characterized by accelerating Allied technological advantages and deteriorating German tactical effectiveness. Grand Admiral Karl Dönitz, promoted to Commander-in-Chief of the entire Kriegsmarine on January 30, 1943, while retaining operational control of U-boat forces, watched his carefully cultivated submarine arm being systematically destroyed by weapons and tactics against which Germany had no effective counters. Statistical analysis conducted at U-boat headquarters in Paris revealed catastrophic trends. In March 1943, U-boats sank approximately 82 merchant ships in the Atlantic, totaling 476,000 tons, while losing 12 submarines. In April, merchant ship sinkings dropped to approximately 56 ships, totaling 327,000 tons, with 15 U-boats lost. May 1943 would become known among U-boat crews as Black May. During this single month, German submarines sank only 50 merchant ships, totaling less than 300,000 tons in all theatres worldwide, while losing 41 to 43 U-boats depending on classification methodology. The exchange ratio had reversed completely. Allies were losing merchant ships they could rapidly replace, while Germany was losing submarines and trained crews it could not. The introduction of Hedgehog represented one component of this broader technological transformation, but its psychological impact exceeded its direct tactical effect. By June 1943, approximately 100 Allied escorts carried the Hedgehog system, with production accelerating to equip additional vessels monthly. German U-boat command began receiving reports from survivors describing the weapon's characteristics. These reports, compiled and analyzed by technical intelligence staff, revealed the weapon's revolutionary nature and its implications for U-boat operations. Corvettenkäpitän Günther Hessler, Dönitz's son-in-law and first staff officer at U-boat headquarters, prepared a classified assessment of the Hedgehog threat based on accumulated combat reports and interrogation summaries from Allied prisoner of war camps. His analysis, circulated to U-boat commanders during briefings before patrol departures, painted a grim picture of technological obsolescence. The British have deployed a forward-throwing anti-submarine mortar designated Hedgehog, Hessler's report began. This weapon fundamentally alters anti-submarine warfare tactics. Unlike conventional depth charges, Hedgehog bombs detonate only on contact with the submarine hull. This contact detonation principle provides the attacking escort with immediate feedback about hit or miss. Tactical implications are severe. The attacking escort maintains continuous ASDIC contact throughout the attack sequence. Depth changes cannot evade the weapon, since the bombs follow the submarine to whatever depth it occupies. The small size of individual bombs creates minimal acoustic distortion, allowing immediate follow-up attacks without waiting for water clarity. Most critically, the weapon appears highly accurate. Multiple combat reports describe attacks where several bombs struck the pressure hull in rapid succession. While our submarines' pressure hulls can sometimes withstand 1 or 2 hits, particularly if they strike reinforced areas, 3 or more hits typically result in critical damage or hull rupture. Recommended counter tactics are limited. Maximum depth provides no advantage since the weapon reaches all tactical depths. High-speed evasive maneuvering drains batteries rapidly and provides only marginal improvement in survival probability. Surfacing to fight with deck guns against destroyers equipped with superior main armament is suicidal. The most effective countermeasure appears to be avoiding detection entirely. Once an escort establishes solid ASDIC contact and begins Hedgehog attacks, submarine survival becomes primarily dependent on luck rather than commander skill or crew training. This represents a fundamental reversal of the tactical situation that prevailed through 1942. Hessler's assessment concluded with a stark warning that would prove prophetic. If the Allies deploy this weapon across their entire escort fleet, as intelligence suggests they intend to do, U-boat losses will become unsustainable, regardless of production rates. We are approaching the point where tactical skill cannot compensate for technological inferiority. Dönitz read Hessler's report with the cold clarity of a commander who understood that material reality trumped operational theory. His submarine force, built and trained around principles of stealth, underwater endurance, and wolfpack tactics, was being systematically defeated by integrated Allied technologies that negated every traditional advantage. Centimetric radar detected submarines on the surface regardless of darkness or weather. Improved ASDIC tracked them underwater with unprecedented accuracy. Hedgehog killed them with precision that made depth meaningless as protection. The combination was devastatingly effective, transforming the Atlantic from a vast hunting ground into a killing zone where U-boats were prey rather than predators. On May 24, 1943, Dönitz made his most painful decision as commander of the U-boat force. He ordered all submarines to withdraw from the North Atlantic convoy routes, effectively conceding tactical defeat in the Battle of the Atlantic. The order, transmitted by encrypted radio to all boats at sea, acknowledged reality that German propaganda would never admit publicly. Due to overwhelming Allied superiority in detection equipment and anti-submarine weapons, North Atlantic operations are temporarily suspended. All boats currently in operational areas are to withdraw to positions southwest of the Azores. Further orders will follow as tactical situation develops. The withdrawal did not end U-boat operations entirely. Submarines continued patrolling in less contested areas, attacking isolated ships where Allied air coverage was thin. But the strategic campaign to sever Britain's Atlantic lifeline had failed, defeated not by any single dramatic battle, but by the cumulative effect of multiple technological advantages that made submarine operations unsustainably costly. The human cost of this technological revolution was staggering. Of approximately 40,000 men who served in U-boats during World War II, approximately 30,000 died, representing a 75% casualty rate. This was the highest loss rate of any military service on either side of the conflict. They died knowing that their equipment was obsolete, their tactics countered, their missions increasingly futile. Yet they continued fighting because duty demanded it, because abandoning the struggle would free Allied forces for other theatres, and because the alternative to continued operations was accepting Germany's inevitable defeat. The technical specifications of Hedgehog that German naval intelligence gradually assembled from combat reports and interrogations revealed why the weapon proved so devastatingly effective. Each of the 24 bombs weighed 32 pounds, containing approximately 35 pounds of Torpex high explosive. Torpex, a mixture of RDX, TNT, and aluminum powder, delivered approximately 50% more explosive power than conventional TNT charges of equivalent weight. The bombs were projected forward from spigot mortars arranged in 4 rows of 6, creating an elliptical pattern measuring approximately 130 feet long by 140 feet wide. This pattern size was calculated to exceed the length and beam of any submarine by sufficient margin that multiple hits were probable if the aim point was accurate. The forward throwing range of 250 yards meant that escorts could attack while maintaining ASDIC contact, eliminating the blind zone that plagued conventional depth charge attacks. The bombs sank at 23 feet per second, reaching 150 meters depth in approximately 22 seconds, 200 meters in approximately 28 seconds. Most critically, the contact pistols were extraordinarily sensitive, designed to detonate upon striking any solid object with force equivalent to hitting the water at terminal velocity. A bomb striking a submarine's pressure hull would detonate, regardless of angle of impact or specific location struck. The precision required was not pinpoint accuracy, but simply placing bombs within the elliptical pattern centered on the submarine's position. German submariners who survived Hedgehog attacks and were later repatriated through prisoner exchanges provided technical intelligence staff with detailed descriptions of the weapon's psychological impact. Kapitänleutnant Werner Henke, commanding U-515, survived his boat's sinking on April 9, 1944, and spent several months in Allied captivity before his death attempting to escape Fort Hunt. During interrogations, Henke described experiencing 3 Hedgehog attacks during his final patrol. "The sound is distinctive and terrifying," Henke told his interrogators. "You hear the splashes as the bombs hit the water above you, creating a pattern of impacts that sounds like heavy rain on a tin roof, then silence as they sink toward your depth. That silence is the worst part. With conventional depth charges, you know they will explode at preset depths. You can calculate approximately when the detonations will occur, prepare the crew for the shock. With this weapon, you have no idea if the bombs will hit or miss. The silence extends for 20, 25, 30 seconds as the bombs sink past your boat. If they miss, you hear them detonating against the ocean floor below, creating sharp cracks that are actually reassuring because they mean you survived. If they hit." Henke paused, his expression revealing the memory of explosions that had destroyed his command. If they hit, there is no warning, just sudden, focused explosions against the hull, far more concentrated than depth-charge detonations. The psychological effect is profound. Depth provides no protection. Evasive maneuvers are useless because the bombs sink faster than submarines can turn. You simply wait in the darkness and silence, hoping the attacking ship's aim was slightly off, knowing that if it was not, you will die in the next 30 seconds. The statistical record of Hedgehog effectiveness validated German submariners' fears. Conventional depth charge attacks achieved kills in approximately 5 to 6% of attacks, where solid ASDIC contact was established and maintained. This low success rate reflected the tactical problems inherent in the weapon's design: preset depth detonation, loss of contact during the attack run, acoustic distortion preventing immediate follow-up attacks, and the submarine's ability to change depth between detection and weapon impact. Hedgehog attacks achieved kills in approximately 25 to 30% of attacks, where solid contact was maintained through the attack sequence. This 5-fold improvement in lethality per attack transformed anti-submarine warfare economics. An escort equipped with Hedgehog could achieve the same number of kills with 1/5 the number of attacks, conserving ammunition while maintaining pressure on detected submarines. More importantly, the immediate feedback from contact detonation allowed escorts to conduct multiple attacks in rapid succession, each attack informed by the results of the previous attempt. If bombs detonated against the seafloor, the submarine was deeper than estimated. Adjust depth calculations and attack again. If complete silence, the submarine had maneuvered laterally. Adjust aim point and attack again. The learning cycle occurred in minutes rather than hours. The Royal Canadian Navy, which operated a substantial portion of the Atlantic escort force, embraced Hedgehog with particular enthusiasm. Canadian escorts, often equipped with less sophisticated ASDIC systems than their British counterparts, found that Hedgehog's contact detonation principle compensated for less precise depth estimation. His Majesty's Canadian ship Edmundston achieved one of the war's most dramatic Hedgehog kills on August 21, 1944. The corvette detected UNE 84 on ASDIC at approximately 0800 hours, establishing solid contact at 1500 yards range. The U-boat, commanded by Oberleutnant Zur C. Horst, Freiherr von Reiswitz und Kaderzin, was transiting the Bay of Biscay en route to operational areas in the Atlantic. Edmundston's commanding officer, Lieutenant James Cuthbert, conducted his attack with textbook precision. The first Hedgehog salvo missed, bombs detonating against the seafloor 100 meters below the submarine's actual depth. The silence told Cuthbert exactly what he needed to know. The U-boat had gone shallower than his initial depth estimate of 200 meters. Reset Hedgehog for 150-meter depth estimate, Cuthbert ordered. Prepare second attack run. The second salvo achieved at least 4 direct hits. The explosions occurred within 2 seconds of each other, indicating multiple bombs had struck the pressure hull nearly simultaneously. ASDIC contact was lost immediately, replaced by the acoustic signatures of a submarine breaking up under pressure. Air bubbles, mechanical noises of internal equipment tearing loose, and the groan of collapsing bulkheads. Within minutes, debris began surfacing: wooden deck planking, cork insulation, articles of clothing, life vests, and the distinctive diesel fuel oil that marked every submarine's grave. There were no survivors from UNE 84's crew of 53 men. The submarine had imploded at approximately 140 meters depth, the combined damage from 4 Hedgehog impacts rupturing the pressure hull beyond its capacity to maintain structural integrity. Edmonton's success typified the Hedgehog's effectiveness when wielded by competent crews with good ASDIC contact. The weapon did not guarantee kills, but it dramatically improved the probability of success compared to conventional depth charges. More importantly, it allowed smaller escorts like corvettes and frigates to achieve kill rates previously associated only with larger destroyers carrying heavier depth charge loads. German technical intelligence struggled to develop effective countermeasures against a weapon that operated on principles fundamentally different from conventional depth charges. The acoustic torpedoes, designated Zahnkönig or T5, introduced in September 1943, were intended to allow U-boats to sink escorts before they could close to attack range. These torpedoes homed on propeller noise, theoretically allowing submarines to destroy attacking ships from beyond visual range. Initial deployments achieved some success, with several escorts damaged or sunk by acoustic torpedoes during convoy battles in autumn 1943. However, Allied scientists quickly developed the Foxer noisemaker, a simple device towed behind escorts that created acoustic signatures mimicking propeller noise, decoying the acoustic torpedoes away from actual ships. More fundamentally, acoustic torpedoes could not address the underlying problem. If an escort established solid ASDIC contact and pressed home its attack, torpedoes offered no defense. The U-boat would be detected before reaching effective torpedo range. Firing torpedoes revealed the submarine's exact position through the acoustic signature of torpedo launch. The escort could evade the torpedo through simple course changes while maintaining ASDIC contact and conducting Hedgehog attacks. Attempts to armor submarine hulls against Hedgehog impacts proved futile. The explosive force of 35 pounds of Torpex, detonating directly against a pressure hull, exceeded the structural limits of any practical armor that could be added without making submarines too heavy to submerge or too slow to operate effectively. Some technical proposals suggested coating submarine hulls with rubber or other materials to cushion the impact of Hedgehog bombs, preventing the contact pistols from detonating. Laboratory testing revealed this approach was theoretically possible, but practically impossible to implement. The coating would need to be several inches thick to provide sufficient cushioning, adding enormous weight and drag. More critically, combat damage or simply extended time at sea would degrade any coating, creating gaps where bombs could strike bare metal. The only effective defense was avoiding detection entirely. If a submarine could remain undetected by ASDIC, Hedgehog posed no threat. But Allied improvements in sonar technology, combined with centimetric radar detecting submarines on the surface and ultra-intelligence revealing U-boat positions before attacks developed, made avoiding detection increasingly difficult. Schnorkel breathing tubes, introduced operationally in early 1944, allowed submarines to run diesel engines while remaining at periscope depth. This reduced vulnerability to radar-equipped aircraft that had made surface operations suicidal. However, schnorkels created distinctive wakes visible to radar, particularly in calm seas. They limited submarine speed to approximately 6 knots. They required excellent seamanship in rough weather to prevent waves from triggering the automatic head valve, creating dangerous pressure fluctuations inside the boat. Most critically, schnorkel-equipped submarines remained vulnerable to ASDIC detection. A submarine at periscope depth running its diesels created considerable acoustic signature from engine noise, propeller cavitation, and the distinctive bubbling sound of schnorkel exhaust. Escorts equipped with good sonar could detect schnorkeling submarines at ranges exceeding 2,000 yards under favorable conditions. U-247, commanded by Oberleutnant zur See Gerhard Matschulat, was detected while schnorkeling on September 1, 1944, by His Majesty's ship Loch Killen, a Loch-class frigate equipped with both Type 271 radar and improved ASDIC. The frigate established contact at 2,300 yards, tracking the submarine for 18 minutes before closing to Hedgehog range. Motionless detected the ASDIC pings and ordered emergency dive to 150 meters, abandoning the schnorkel. This tactic might have succeeded against conventional depth charges, but Hedgehog's contact detonation followed the submarine to its new depth. The first salvo achieved 2 hits, damaging the stern section and jamming the rudder hard to starboard. Unable to maneuver effectively and taking water through cracked seams, U-247 was forced to surface. The crew attempted to man deck guns, but Loch Killin's 4-inch main armament destroyed the submarine's conning tower with the first salvo. 41 crew members survived to be pulled from the Atlantic. 12 men died in the attack or drowned before rescue. During interrogation, Motionless provided technical intelligence officers with a remarkably frank assessment of German countermeasure efforts. "We knew about the Hedgehog by mid-1943, Motionless stated. Technical intelligence briefings described the weapon's characteristics before we sailed on patrol. We were told it detonated on contact, that it was thrown forward maintaining ASDIC contact, that multiple salvos could be fired in rapid succession. But knowing about the weapon provided no effective defense. We could not armor against it. We could not evade once detected. The schnorkel allowed us to avoid radar detection while charging batteries, but it did nothing against sonar. The only real defense was staying away from convoy routes where escorts concentrated. By late 1944, this meant we were operating in areas where target density was so low we could sail for weeks without seeing a merchant ship. We were hiding from the enemy rather than hunting them. The strategic situation had reversed completely. The weapon that made this reversal possible was not just Hedgehog, but Hedgehog combined with improved sonar, centimetric radar, and intelligence that seemed to predict our every movement. The integration of multiple allied technologies created a layered defense that made U-boat operations statistically suicidal by late 1944. Ultra-intelligence revealed Wolfpack assembly points and patrol areas. Centimetric radar detected submarines attempting to surface for battery charging. Improved ASDIC tracked them underwater with unprecedented accuracy. Hedgehog killed them when they tried to evade. Statistical analysis prepared by the Operational Research Section at Royal Navy Western Approaches Command quantified this transformation. In 1942, the probability of a U-boat completing a patrol and returning to base was approximately 75%. By late 1944, this probability had dropped to approximately 25%. The average U-boat lifespan measured from commission to destruction was approximately 11 months in 1942. By 1944, it had dropped to approximately 3 months. The human cost of this technological transformation fell most heavily on young men who had volunteered for submarine service, believing they were joining an elite force that would determine the war's outcome. Instead, they discovered they were serving in an increasingly obsolete branch that continued operations primarily to tie down Allied anti-submarine forces that might otherwise be deployed elsewhere. Oberleutnant zur See Peter Dönitz, Admiral Dönitz's younger son, died aboard U-954 on May 19, 1943, when his submarine was destroyed by British escorts using Hedgehog during attacks on convoy SC-130. The loss of his son did not alter Dönitz's operational decisions. The U-boat campaign continued because strategic necessity demanded it, regardless of personal cost. By early 1945, the situation had become hopeless. Allied shipyards were producing merchant vessels faster than U-boats could sink them even if every torpedo found its target. The Liberty ship program alone produced over 2,700 vessels during the war, replacing losses faster than German submarines could inflict them. Meanwhile, U-boat losses had reached levels that made experienced crews increasingly rare. The average age of U-boat commanders dropped from 32 years in 1942 to 26 years by 1945. Many boats sailed with commanders who had never experienced combat, leading crews who had spent more time in training than at sea. The quality decline was inevitable, given 75% casualty rates among submariners. The experienced men who might have trained the next generation were dead, drowned in the Atlantic by weapons they could not effectively counter. The revolutionary Type 21 electro boat, with its streamlined hull and massive battery capacity, allowing sustained high-speed submerged operations, might have changed this calculus had it entered service in quantity during 1943. But production, delays, Allied bombing of manufacturing facilities, and chronic shortages of critical materials meant only a handful became operational before Germany's surrender. U-2 511, the first Type 21 to conduct combat operations, sailed on April 30, 1945, commanded by Corvettenkäpitän Adalbert Schnee, one of Germany's most experienced submarine commanders. On May 4th, Schnee detected a British cruiser task force and executed a perfect attack approach, reaching firing position undetected. He did not fire. Germany had already announced surrender negotiations. Schnee surfaced and radioed his position, ending the U-boat war not with violence but with recognition of defeat. The final statistics of the Hedgehog's contribution to Allied victory remain difficult to quantify precisely because the weapon was one component of an integrated anti-submarine warfare system. Records indicate that Hedgehog-equipped escorts achieved approximately 50 confirmed U-boat kills during the war, though some sources suggest the number may have been higher if all kills where Hedgehog was employed, but other weapons delivered finishing attacks are included. What cannot be disputed is the weapon's psychological impact and its contribution to the overall transformation of anti-submarine warfare that defeated Germany's U-boat campaign. The contact detonation principle, the forward-throwing design, maintaining sonar contact, and the immediate feedback, allowing rapid attack adjustment, represented genuine innovation that forced fundamental changes in submarine tactics. German submariners who encountered Hedgehog and survived carried their experiences back to port, spreading word of the weapon's capabilities throughout the U-boat force. This information flow, inevitable in any military organization, served Allied purposes by reinforcing the demoralization already caused by mounting casualties and technological inferiority. The interrogation reports, combat, diaries, and post-war memoirs of German submariners consistently emphasize the psychological impact of weapons that provided no effective defense. They describe the helplessness of waiting in darkness while Hedgehog bombs sank toward their depths, knowing that survival depended entirely on whether the attacking ship's aim was accurate. They explain how this helplessness, repeated across hundreds of engagements, transformed confident warriors into fatalistic survivors who measured success not by ships sunk but by patrols survived. They document the transformation from offensive operations seeking convoy battles to defensive operations focused primarily on avoiding detection. This psychological transformation, as much as the physical destruction of submarines, represented Hedgehog's strategic contribution. A weapon that made experienced U-boat commanders question their ability to survive through skill and training was a weapon that had achieved victory at the most fundamental level. It had replaced confidence with fear, aggression with caution, and offensive spirit with defensive fatalism. When German naval forces surrendered in May 1945, approximately 156 U-boats remained operational from a force that had peaked at over 400 boats in early 1943. Operation Regenbogen, echoing the scuttling of the High Seas Fleet at Scapa Flow in 1919, resulted in many commanders scuttling their boats rather than surrendering them to Allied forces. The men who survived, representing only 25% of those who had served in U-boats during the war, carried memories of technological obsolescence and tactical helplessness that shaped their understanding of why Germany had lost the Battle of the Atlantic. They spoke not of superior Allied seamanship or courage, qualities both sides possessed in abundance, but of systematic technological advantages that made skill increasingly irrelevant to survival. In post-war interviews and memoirs, survivors consistently identified specific weapons and technologies that had transformed submarine warfare. Centimetric radar that detected submarines in any weather, ultra-intelligence that predicted wolfpack positions before attacks developed, improved sonar that tracked submarines with unprecedented accuracy, and Hedgehog, the forward-throwing mortar that killed with precision that made depth meaningless as protection. The weapon's influence extended beyond its immediate military applications. The contact detonation principle influenced post-war anti-submarine weapon development, leading to more sophisticated homing torpedoes and missile systems. The forward-throwing design informed modern ship-launched weapons that maintain sensor contact throughout the attack sequence. The operational research methods used to optimize Hedgehog employment became standard practice in military technology development. Most significantly, Hedgehog demonstrated that incremental improvements to existing weapons could achieve revolutionary results when combined with tactical innovation and systematic analysis. The weapon itself was not exotic or unprecedented. Forward-throwing mortars had existed for decades. Contact detonation pistols were established technology. The innovation lay in combining these elements in ways that addressed specific tactical problems identified through operational research. This methodology, analyzing combat operations to identify inefficiencies, developing technical solutions to address those inefficiencies, and rapidly deploying solutions to operational units, became the model for modern military technology development. The scientific approach to warfare, where probability and statistics guided tactical decisions as much as commander intuition, originated in part from the operational research that produced weapons like Hedgehog. For German U-boat crews who heard the distinctive sound of Hedgehog bombs striking water above their submarines, then experienced the terror of waiting in darkness, wondering if those bombs would strike their hull. The weapon represented something more visceral than technological innovation. It represented the end of an era when submarines could operate as invisible predators, the death of tactical doctrines that had dominated naval warfare since the First World War, and the birth of a new form of combat where sensors and precision weapons trumped stealth and endurance. They had entered the war believing their U-boats were invincible weapons that would starve Britain into submission. They discovered instead that they were serving in an obsolete force, being systematically destroyed by enemies who possessed technological advantages so profound that courage and skill provided no compensation. The shock of this discovery, repeated in thousands of engagements across the Atlantic, marked the psychological defeat that accompanied and reinforced the physical destruction of U-boat force. The sound of Hedgehog bombs striking water became, for German submariners, the sound of technological obsolescence made audible. It announced the arrival of weapons they could not effectively counter, tactics they could not successfully evade, and a form of warfare where the electromagnetic spectrum mattered more than traditional naval skills. It was the sound of the future, and it terrified them precisely because they understood its implications for their survival and for Germany's strategic prospects in the Atlantic. When the last U-boat surrendered in May 1945, when the final survivors were pulled from the Atlantic and interrogated about their experiences, they spoke consistently about specific moments when they realized the war was lost. For many, that moment came not during any dramatic battle but during the 30 seconds of silence after Hedgehog bombs hit the water above them, waiting to learn if they would survive the next few seconds. In that silence, in that helpless waiting, they confronted the reality that technology had rendered their submarines obsolete and their tactics futile. The Battle of the Atlantic had been decided not by any single engagement, but by the cumulative effect of multiple Allied technological advantages deployed systematically and relentlessly. Hedgehog was one weapon among many in this integrated system. But its impact exceeded its individual contribution because it embodied the principle that would determine modern warfare. Precision weapons guided by sophisticated sensors, deployed by forces possessing complete tactical awareness, would defeat even the most courageous opponents if those opponents lacked equivalent capabilities. German U-boat crews learned this lesson in the most brutal way possible, through the destruction of 3/4 of their comrades and the eventual defeat of their entire campaign. The sound of Hedgehog bombs striking water became their education in the reality of technological warfare. It was a lesson written in explosions against pressure hulls, in the groaning of steel under impossible stress, in the drowning of men trapped in steel coffins, and in the statistical certainty of defeat when courage alone could not overcome systematic material disadvantage. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.